Hello students. So we had discussed about the forces and the superposition of forces, right? So let's now try to do a couple of questions. So we'll try to see as to how do we apply the forces. The first question, let's try to understand how much what exactly is going to be the ratio of forces as compared to when we talk about a gravitational force and an electric force. So let's try to find out the value. So if I say for the two charges, both the charges, let's say, have the same mass, that is charge Q1 is equal to charge Q2, they have the same mass as, let's say, 9.1 into 10 to the power minus 31. I'm taking the case of electrons itself, and both of them have the same charge, that is minus 1.6 into 10 to the power minus 19 coulombs. Okay, so in that case, if we are required to find out the ratio of the gravitational force and the electrostatic force, so how do we get it? So Fg, if I have to say for the gravitational force, so this is going to be equals to, is going to be given by G m1 m2 divided by distance of square, assuming they have been kept at some distance away. So if you put in the values, so this will be equals to 6.67 into 10 to the power minus 11 into the masses. Masses are going to be 9.1 into 10 to the power minus 31 whole square divided by the distance square. And if I have to talk about for the case of the electrostatic force, so let's say the electrostatic force, so this is going to be given by 1 over 4 pi epsilon naught, so that can be written as 9 into 10 to the power 9. Then masses, the charges, that is 1.6 into 10 to the power minus 19 whole square of this whole divided by r square. So this way, if you just use a calculator or even without a calculator, you can find out what is going to be the ratio between these two, right? Okay. Going over to the next question, let's say the next question is that supposing we are required to find out the net force. I am given something like this. So this is a square, let's say, square of side A. Okay. Now I give it at all the points. I'm giving it the same amount of charge. So let's say the charges that are there, let's say Q, 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 Q. All the charges are exactly the same. Let me name them. This is A, B, C, D, right? But what exactly is my question? My question simply is, I want to find out the net force on the charge C due to all of these. So what will I get? How to find it out? We'll just be joining like this, similarly like this, and like this, right? So these are the three forces that are going to be existing, am I right? So now, if I have to go further on this, so what will I do as a result? So horizontally, I'll say that this is the force FCD. Along this diagonal, there is the force FAC. Vertically down, it is the force FBC, right? So these are the three forces that are acting here. Now, as you can see, these are the different directions, so I cannot use the superposition rule. It's not going to be helpful. But I know that this angle is going to be 45 degrees. So this angle is again going to be 45 degrees, right? So let me use this. So I'm going to use simple trigonometry. So what I'm going to do, I'm going to take a projection like we had discussed in vectors. I'll take a projection of FAC along FCD. So what will I do? I will write this as FAC cos 45, and let's assume that this is nothing but Fx. Similarly, along the vertically downward direction, so this can be written as FAC sin 45, and this is nothing but Fy. Am I clear? So I now have, it has become very simple. So I now have two forces. So one is, what is Fx? So Fx will be equals to FCD plus FAC cos 45. But what is the value of FCD? Let's try to figure it out. FCD is going to be given by, FCD is just this. So the charges are the same and the distance is A. So this can be simply written as K Q square upon A square. And if you do not take the directions into account, this value is the same as the force FBC. Right? Further, if you look into the figure, this side is A, this side is A. Therefore, the diagonal would have a value which will be equals to A root 2. Right? So, using that, if we want to find out, so FAC value is going to be how much? It's going to be equals to K Q square and divided by, it's going to be A root 2 whole square. Right? So if you simplify this, so this is going to become KQ square upon 2A square. So we are required to use this relations out here. So let me remove this from here such that, what will I get? If I want to find out for Fx first, so Fx, FCD is this. So KQ square upon A square. Then it is FAC cos 45. So I can simply say it's going to be KQ square upon 2A square into cos 45, that is 1 over root 2. Okay? And the same value, if you put in here, and the same value is going to be for Fy as well. That is KQ square upon A square plus KQ square upon 2 root 2 into 1 by A square. Okay? So we have Fx, we have Fy. So let me remove everything else now. So now I have to just simplify this. So what I'm going to do, let me rewrite this here. So Fx value, I will only solve for Fx, Fy which is the same. So Fx, here I can simply write it as KQ square by A square, and here I'll get 1 plus 1 over 2 root 2. Okay? So what will I get as a result? So this can simply be given by, and similarly we will have Fy. So Fy will also be equals to KQ square upon A square, and here I'll get 1 plus 1 over 2 root 2. So the net force, if I want to write it down, net force is going to be Fx with the I cap plus Fy with the j cap, right? So if I put in, so I can simply write this as KQ square upon A square into 1 plus 1 over 2 root 2, and here I can simply say I cap plus j cap, right? So this is the vector, and if I want to find out the magnitude of this, so the magnitude of it is going to be, this part is going to remain the same. So I can simply say is KQ square upon A square, and here I'll get 1 plus 1 over 2 root 2. Now if you take a square root of this, so this is going to be equals to square root of 1 plus square root of 1, means 1 square plus 1 square. This is going to be root 2. We multiply that root 2 factor inside, so the result comes out to be KQ square by A square. Here you will get root 2 plus 1 over 2. So this is going to be the net force, right? So this way you can actually figure out what exactly has to be done. You do not have to find out the unit vectors, you don't really need to do anything else. So this actually simplifies our life considerably. Okay. Let's now go into the next question. What exactly it is, let me tell you. Okay, so the next question goes as follows. Please try to understand it very clearly. I have two charges, Q and Q. Okay. This I am placing it as at minus a comma 0. This I am placing it at a comma 0. Okay. Now, if I say that at the origin, because origin is going to be lying halfway between these two. So at the origin, if I have a charge, let's say Q by 2, and firstly, if I want to displace it along the x-axis, so let's displace it either along the charges. So let's say I displace it by a distance x along the x-axis first of all. Then we'll do the same thing for the case of y-axis. So if I am displacing it along the x-axis, so what will I get? Let's say the new position is somewhere here. So from here to here, the distance is going to be how much? A minus x. And similarly from here to here, the distance, mind you, this is minus a, but this is the distance from origin to this point is exactly equal to. The distance from the point this to here is going to be a plus x, right? Now, okay, so this is what we have. Now the foremost thing. All the three charges are of the same type, right? Therefore, what will we get as a result? We'll say that the net force that will be acting on this charge Q by 2 is going to be additive. So the net force, I'm just going to add it up. So I can simply say K, capital Q into Q by 2, whole divided by, firstly if I say this one, so it's going to be A minus x whole square. Secondly, I take this one, so I'll get K, Q into Q by 2 divided by A plus x whole square, right? So I have these notations. Now, what is the thing that needs to be considered here further? Here, we are trying to find out the net force on this particular charge, right? So that's the reason from this particular charge, the force will be in this direction. I'll just like to clarify one thing here. From this particular charge, the force is towards this. It's going to be away. As well as from this particular charge, when we take it, it's going to be this way, right? So the net force when we try to find out, I should have been more careful, actually has to be subtracted. So either way, it doesn't matter whether you place one first or the other first. So this tells you that the direction, it is along this particular direction, that is towards the left hand side. So this being more, this being less, so that's the reason we have just subtracted this. And why you have subtracted it, even though the charges are the same, the reason being, let me explain again. From this charge Q, you will be exerting a force towards right. From this charge Q, you will be exerting a force towards left, right? As a result, if I now want to simplify this and see what we get, so let's try to simplify this. So the factor, if I just rewrite this, so K Q square over 2 factor, if I take it out common, I'll get A plus x whole square, I'm taking an LCM, and minus A minus x whole square, whole divided by, it's going to be A square minus x square whole square. Okay. So this is what we have. Now, from here, if I say kq square over 2, if I expand this, I'll get a square plus x square plus twice ax, and from this one is going to be minus a square minus x square plus twice ax whole divided by a square minus x square whole square. Yeah? So let's see, a square square a square x square goes off. Therefore, I will simply be left with kq square here, and here I will get twice ax divided by a square minus x square whole square. So this is the net force that will be acting on the charge q by 2 when it is displaced from the x-axis. Right? Okay. Now let's try to do the same thing when it is being displaced along the y-axis. Let's see what we get as this. Okay. So putting the same figure again, I have the charge q, I have the charge q minus a comma 0 plus a comma 0. The distance between them is r, and sorry, the distance is not concerned. Okay, these are placed along the x-axis. Further, if I from the origin, if I am taking charge by a distance x or let's say y along the y-axis, charge is q by 2, then what will be the net force acting on the charge q by 2? So how do we do it? As we know, from the charge q is going to be repulsive force. So this is going to be the direction from this particular charge q, and from here this is going to be the direction. It's actually, it should have an intersecting, sorry for that. And since they have been placed equal distance away from the origin, so let's say theta is the angle. Theta is going to be the angle across both of them. The distance from this charge to O is A, and from here to O is A as well. So these are the two distances that we take. So effectively, how much is going to be this distance? So this distance is going to be equal to square root of a square plus y square, and similarly this distance is going to be square root of a square plus y square. Okay? So what we get as a result? How do we solve this? So when we have to solve this, as you can see, both the forces are pointing in opposite directions, different directions. So what we have to do, we have to find out components in this. So how do we find out the components? Let's say there is going to be a component along the horizontal direction of both the forces, and both the forces will have a component along the vertically upward direction as well. So the horizontal components are just going to cancel out. So this will cancel out with this one. So only the vertical component is going to stay back. Okay. So, okay. Further, if I name this, let's say this is A, this is B, this is O, let's say. So what we will get as a result? We'll find out the net force at the point O. The net force at the point O is going to be given by AO. The net force basically is going to be along the sine theta direction. This is going to be equal to FAO sine theta, right? Because this angle is theta, so this angle will also be equal to theta, and therefore it's basically the vertical direction that we are referring to. So we have FAO sine theta plus is going to be equal to FBO sine theta. Okay. Since the magnitudes are exactly the same, so we don't have to worry about that. We can simply say that's equals to twice of either FAO or FAO, doesn't matter. So this is what we have. Clear? Now what is the value of FAO? Let's figure out what is going to be the value of FAO. The value of FAO is going to be equals to K is going to be Q, is going to be Q by 2, and the distance is going to be equals to square root of a square plus y square whole square. So this is going to be the value, and therefore if we put in here, so what will we get as a result? We'll get twice k q square divided by 2, and here you will get a square plus y square into the sine theta value. Sine theta is vertical, so it's going to be y divided by root over a square plus y square. Okay? So if I cancel out these parts, let's see what we get. Right here itself. So the net value of force is going to come out to be equals to k q square y divided by a square plus y square raised to the power 3 by 2. So this is going to be the net force on the charge q by 2 when it is taken along the y-axis by distance y. Then we are taking it along the horizontal direction, so the distance was x. So this is the net result that we get. Generally what we do is that we will approximate, we'll say that this distance is, this y distance is going to be much less as or the other way around. Oh sorry, we take the distance a to be considerably less as compared to the value exactly you're trying to measure. So when you do that, so effectively this is going to in that case become just q square divided by y square, because this will become cube and there was a y factor, so they are just going to cancel out. So depending upon an approximation, we haven't approximated, so this is the result that you get without an approximation. Okay, so hopefully the questions are clear. So this is how we will actually go further with the concepts of force, electric force. In the next topic, in the next session, we'll be discussing about what exactly is electric field. What exactly do we get in the case of an electric field, right? So meet you then. See you. Thanks for that.